Hello and welcome. It's time to take a look into supervised machine learning. So guys, whenever I pick a new subject, I always look at its root word, right? So here we are learning supervised machine learning. So what is the root word here? If you ask me, the root word here is supervisor, right? So now you might ask, who is a supervisor? So supervisor is a person who is in charge of a group and who makes sure that the work is done correctly, accurately, and as per the rules. So that is a supervisor. Now, somebody who's coined this term supervised machine learning, why are they calling it as supervised? Why it is called supervised? Because it is based on the labeled data set. Now, that's the beauty of supervised machine learning, because you are labeling your data set, right? Like we took the example of cat and a dog, where we said you are giving a feature, you are giving, let's say, 3 features: type of nose, type of ears, length of the ears, and then you are labeling it's a cat, it's a dog, right? So a labeled data set is a data set where data is clearly annotated with meaningful tags or labels that classify the outcome. So you already know the outcome, right? And these data sets are designed to train or supervise the algorithm. So if somebody asks you who is the supervisor here, you will say the labeled data set is the supervisor. Labeled data set is the supervisor, right? So let's take a look. So the supervised learning involves training a model on a data set that includes both input data and corresponding correct output. Now here we'll take an example of the iris flower, right? Iris is a flower, and here what we are doing is we are actually, and there are different types of iris, right? Or the various varieties of iris. It could be a setosa, it could be a veris color, or it could be a virginica, right? So as part of that, and all these would differ based on the features, like what is the sepal length, sepal width, petal length. You can identify whether which class of the iris flower does it belong to. And first of all, sepal is nothing but the outer part of the flower, which is normally like the green part, right? That is your sepal, and petals we all know, right? So what I want to make sure, or what I want to tell you, is that this is the kind of an input you are giving, but you already are giving the output as well, right? You are labeling your data. So that's why it says it's a data set that includes both input data. What is my input data? Input data is sepal length, sepal width, petal length, petal width, and the corresponding output. The corresponding output is whether it is a setosa, whether it's a veris color. So the aim is that if I'm giving thousands of data, thousands of rows to my model based on these features, it can come to know, okay, if this is the length, width, petal, then it should fall under which categories. Again, we are talking about finding the patterns in data to give the right prediction of the data, right? Okay, so as I said, it's a labeled data. The training data set must be labeled, meaning each example is paired with correct answer. Very, very true. As you can see, we are giving all the length, width of petal and sepal, and we are also giving the the correct answer, like what class it belongs to. Okay, and there are different algorithm types in supervised machine learning. You could talk about linear regression, logistic regression, SVMs like support vector machines, decision trees are there, neural networks are there, which you'll actually study in deep learning as well. Okay, so the training process is pretty simple. What we just learned in the machine learning workflow, the model learns a function that maps the input to desired output and makes prediction based on that function. So it's pretty simple, right? You are learning based on the training data. You are able to identify the patterns, and then you can make predictions. As simple as that. Just think about it. Let's say I feed this data, right? If I feed this data, which is new data, and to the computer or to my model, if I give 5.9, 3.0, 5.0, 1.8, The model should be that accurate that it should be able to tell me, hey, based on this input data, it is a Virginica. That's what is the aim of this, right? Yes, and the supervised machine learning normally has a risk, and risk is of overfitting. Overfitting is nothing but we are just saying that it can give you inaccurate results, right? The results are not accurate if the unseen data is given to it. So one way is that you something that the computer already knows of, that's fine. But what if you give some unseen data to it? Obviously, you won't get the accuracy with that. So supervised machine learning models can overfit the training data, meaning they may not perform well on new or unseen data, right? So with training data, everything is going well, your model is performing, but suddenly some unseen data comes up, which the model is not aware of, and it can give you inaccurate results, right? So what are the applications? Now you might say it can be used in various applications like image recognition, right? We did the example of a cat and a dog. Like if I'm giving a lot of images, the computer is able to identify which is a cat, which is a dog, right? And same way, speech recognition. A lot of say banks are using speech recognition software these days. So normally with HSBC, I've seen that they say that my voice is my password. So if I say that, it is able to recognize that my voice is actually my password. So if somebody else tries to say these lines, the computer will identify that it is not this person, but some other person trying to enter the account, right? Same way it is used in medical diagnosis. Spam detection, we already saw the use case, which was where we talk about whether it's a spam or a not spam email, which is like a ham, and it also used in a stock price prediction as well. So with supervised machine learning, we have two types, which is classification, which is used for sorting items into different categories. As you can see, we are sorting. Or there is regression, which is identifying the real values, which is talks about the continuous values, right? So don't worry, we'll take a look into the types of supervised machine learning in the next videos. What is classification? What is regression? Thanks for watching.